We the project members excited to share our innovative the Matka cooling refrigerator, an eco-friendly refrigerator concept inspired by India's traditional cooling techniques. This idea combines ancient wisdom with a touch of modern innovation to create a sustainable low-cost alternative to electric refrigerators. Now, this is the presentation of our project. Let's follow through the introduction part. Introduction traditional means modern. Traditional clay pot matka combined with modern solar technology. Internal circulation, fans circulate air inside the matka to cool contents efficiently. Completely off-grid, zero electricity cost, powered entirely by the sun. Multiple applications, ideal for food preservation, water cooling and storing perishables. How it works? Evaporation cooling. Water seeps through porous clay and evaporate, creating a natural cooling effect. Solar panels capture sunlight and convert it to DC electricity for powering the system. Internal fan powered by solar panels circulate air inside the matka continuously. Forced convection. Moving air accelerate heat removal from contents stored inside. Enhanced cooling combines achieve impressive 8 to 10 degree temperature reduction. Now let's move to the key benefits: 100% renewable, zero running cost, no grid required, low maintenance, and environmentally sustainable shelf life. Now let's move to the performance data. The innovation really give us a huge temperature reduction of 8 to 10 degree, affecting make a cooling efficiency 70 to 82% and energy consumption to a 0 kilowatt per hour and 100% on solar. That means on the natural power consumption. The self-drive extension leave greeny from 1 day to more than 4 days. Tomatoes from 4 days to 11 to 18 days. Vegetable from 2 days to 7 to additional storage. Now let's do the technical specification. Solar panel from 50 to 200 watt capacity, fan power 15 to 25 DC consumption, water capacity 10 to 15 liters, pot size dependent, and effective cooling area like 10 to 15 meters square. Backup operate during sunlight hours. Lifespan 5 to 10 years depending upon the condition of the solar panels. Now let's move to applications: rural food preservation, farmer storage, water cooling, emergency cooling, community installations, and commercial use. Now let's move to the optimal operating condition: the climate, the humidity below 40% relative humidity, temperature above 25 degree ambient, and sunlight direct exposure of solar panels. Now ventilation, well ventilated area for evaporation, maintenance 1 to 3 liter refills per day. Now passive versus active cooling. Passive traditional matka cooling 3 to 6 degree reduction, relies on natural convection only, slower cooling rates, take longer to reach temperature. Active solar fan enhance cooling 8 to 10 degree reduction, forced air circulation, 3 to 4 times faster cooling rates, rapid temperature drop, 85% recommended. Now let's move to the economic impact. It really impacts the initial cost, the operating cost, the ROI, the electricity bills, food loss reduction, and income boost. Also a successful attempt. Now let's move to environmental benefits: zero carbon emissions, renewable energy, biodegradable materials, water efficiency, no chemical refrigerants, reduce food waste, and many more. Let's do the real world success. India. Mitticool sells thousands of clay refrigerators daily, revolutionizing rural food storage. Rajasthan, solar milk chillers of 700 plus hurting families, increase income by 4 times. MIT D-Lab, forced air system cools 300 kg of products produced in just 6 hours. Nigeria, pot-in-pot colors awarded prestigious Rolex Enterprise Award. Kenya, 82% cooling efficiency achieved in comprehensive field tests. Now let's move to the design innovations: internal fan placement, optimized solar place sizing, sealed lid design, ice pack integration, hybrid options, and IoT sensor are installed. Now let's move to the challenges and solution: low efficiency in humid climate areas, use in dry regions, less than 40% humidity for optimal performance. Challenge: nitty time operation, add battery backup for cooling pads for 24/7 cooling. Challenges: limited cooling capacity, use multiple units or larger matkas for increased storage. Now the challenge: initial setup cost, government and subsidies, microfinance program available. Now let's move to the conclusion part. Innovation fusion of ancient and modern technology address climate change and energy poverty, province effectiveness 4 to 70 shelf life extension, sustainable affordables and practical solution, performs off-grid and rural communities. So that's the presentation of our innovative project.